Good morning, ladies and gentlemen. Today, we are going to talk about functions. And this is going to be a little bit of an odd lesson, and I'm going to try to let it be a little bit exploratory on your part, because I don't want to just sit there and feed you answers. I want you to try to kind of think through some of this stuff. Now, I'm not going to ask you to think through anything that you have not already done in class, so please take heart. But what I want to do is I want to go back to Algebra 1 when we looked at functions like this right here. Okay, and if someone said, I want you to graph that function, I mean, all of us knew that that was really the same as y equals 3x plus 2. And then after time, we learned different things about that. We knew that this was the slope and this was the y-intercept. And so we kind of knew how to graph it. But when we started these, and you had to graph it, the very first thing that you were instructed was to make an x and y table, because we didn't know this whole idea about slope and y-intercept yet. And so we were told, hey, make an x and y table. And the idea was that what we're going to do is we're going to plug in some x values. And I'm going to say something like, maybe we do -2 and -1 and 0 and 1 and 2. Okay, we plug in some negatives. It's always a good idea to plug in 0, and then we plug in some positives. And when I say plug them in, what I'm saying is we're going to put those for the input, for the x. Okay, and so in other words, we would say, well, f of -2 is the same thing as 3 times -2. I put that -2 in place of x plus 2. 3 times -2 is -6, plus 2 is -4. So therefore, my output value, my y value, is -4. That's associated with -2. I'm not showing you anything new. I'm showing you stuff actually that's incredibly old, but I'm just going to keep walking through this concept for a second. And then I could plug in -1. That would be 3 times -1. And 3 times -1 is -3, plus 2 gives me -1. So therefore, again, the y value that associated with the x value of -1 is -1. And then you could say f of 0 is equal to 3 times 0 plus 2. So that, of course, is 2. So we go, great. Okay, I plug in a 0 and I get 2. F of 1 is equal to 3 times 1 plus 2 is equal to 5. And so therefore we get that this is a 5. And last, we could say f of 2 is equal to 3 times 2 plus 2, which would give me 8. Now, we see enough that we could go, man, we see the slope and the rise over the course of the run on these. And so we know that because we already know that because this is y equals mx plus b. All right. But let's say we just were stuck with the idea of going, hey, we plugged in a bunch of points on an x and y table, and now we want to plot those points. And so what we would do is we'd, create our graph. It looks something like this. Here's our y-axis. Here's our x-axis. And we say, okay, so when x was -2, boom, 1, 2, we have to go down 4. 1, 2, 3, 4. And so that's about here. Okay, when x is -1, we could go down 1. So that's here. When x is 0, we're at 2. So that's 1, 2 here. Okay. When x is 1, we're at 5, 1, so we got to go up 1, 2, 3, 4, 5 right here. And when x is at 2, we're at 8. 2, we're at 1, 2, 3, 4, 5, 6, 7, 8. Okay, right here. And you can see, we do. Now, not a perfect graph. I kind of got away. My lines aren't perfect. But anyway, that's what we do. We have inputs. We plug those inputs into a function. We get outputs. When I'm referring to outputs, I'm referring to the y values. We get outputs, and we can plot them because we see all of these not as just these two values, but these are ordered pairs. Remember, these are like points. Okay, and that's all we're doing is we're going, okay, so that's the 0.02. This is the 0.15. This is the 0.28. All right? Okay. Could not be easier. Something you guys could do blindfolded upside down while you're sleeping underwater. It's so easy. But what we're going to do is now we're going to take that idea and we're going to apply it to trig. So let me tell you. So for instance, what if I said our function of x is now equal to sine of x, or in other words, y is equal to sine x. Now, the reason why this is a little bit weird is because we have been seeing the output of these different trig functions as points. And so now we're kind of stepping away from that. We're not thinking about the unit circle so much. We need to get some values from the unit circle, but we're not thinking about the points on the unit circle. We're thinking about the output, the way the unit circle teaches us what different sine values are. And the way the unit circle teaches us what different cosine and tangent and cotangent, secant, cosecant. Okay? So, for instance, what I'm going to do is we're going to take this idea of this function right here, and we're going to plug it in with an x and y table in the hopes of being able to graph that function. So, for instance, now the only thing I forgot to put is I didn't put 0. That was silly. It's always a good idea to have 0. Hang on, I want to get rid of this. And bring those guys up just a little bit more. Bring this guy up. Boom. And now we got room for 0. Okay. So we'll say, here's 0. So what I'm doing is I'm plugging in 0 right here, which is to plug it in right here. And you think, what is the sine of 0? Well, at 0 degrees or at 0 radians, what's the y value? The y value is 0. Okay. And then you go, what's at pi over 6? What's the y value? It is 1/2. At pi over 4, it's square root of 2 over 2. At pi over 3, it's square root of 3 over 2. Now, where am I getting these values? Well, these are, now this is a little bit weird, because these are the y values, and of course I have the y right here, but that y, it doesn't matter, because I could have also said, hey, we're going to do f of x of cosine of x. And so then we would be paying attention to our x coordinates off the unit circle, okay? So this is what I need you to do is ultimately, right now, if this sounds confusing, take a deep breath and relax and go, this is not that bad. I have to just pay attention to my input values and what are the corresponding output values, okay? And what I'm going to do is I'm going to do both sine and cosine real quick, okay? And so let's finish before I even get into cosine. Let's finish sine. Okay, sine of pi over 2. Pi over 2 is, up at 90 degrees. What's the y value? Y value is 1. And then past that, it's square root of 3 over 2. Square root of 2 over 2 at 3 pi over 4. And at 5 pi over 6, the y value is pretty small. It's just 1/2. At pi, the y value is 0. At 7 pi over 6, that's when the y value is negative. And now it's negative 1/2. And then 5 pi over 4 is still in the third quadrant. So it's negative square root of 2 over 2. 4 pi over 3 is negative square root of 3 over 2, and 3 pi over 2 is negative 1. And then 5 pi over 3 is almost to negative 1, but it's negative square root of 3 over 2. 7 pi over 4 is negative square root of 2 over 2. 11 pi over 6 is negative 1/2, and 2 pi is 0. Now, you go, okay. Now what I've done, notice where I've kind of placed these tick marks on my x-axis. Notice they're kind of grouped, and then they're gapped, and then they're grouped, and then they're gapped, and then they're grouped. That's because if you think about these values, and let's just talk about them in terms of degrees, it'd be easier for a second. 30 degrees is obviously 30 from 0. But then to get to 45 degrees, it's only a 15-degree gap between these two. And to get to 60 degrees, it's only a 15 gap between these two. But then the next one is 90, so it's another 30-degree gap. So that's why they're going to be kind of clumped like that. And then I jump all the way to 120, 30 degrees, but then only 135, 15 degrees. And then 150, 15 degrees. But then all the way to 180, 30 degrees. So that's why I have those points or those tick marks like that, because that's how our angles actually look, okay? Now, let's start plotting points, okay? So we're going to do this. 0, 0. Where is 0, 0? That's an easy one. Origin. Boom. Okay? And then what about pi over 6 is 1/2? So pi over 6 is this first one. 1/2. That's easy. I'm just going to go up 1/2. Okay? Now, when it comes to square root of 2 over 2 and square root of 3 over 2, that's where it would really help. I love to have these exact values, but it would really help for me to have some kind of decimal approximation. Okay? And so what I do here is I go, okay, square root of 2 over 2 is about 0.7. And then square root of 3 over 2, I believe, is about 0.87. okay? And obviously 1/2 is 0.5. All right. So if I operate on those, then that's enough information for me to be able to do this. Okay. And so I go, all right. So now at the 45 degrees at pi over 4, I'm jumping all the way up to about 0.7. So that's going to be just about here. At pi over 3, I'm all the way up to 0.87. So that's going to be about here. And then at pi over 2, I'm all the way up at 1, right here. Okay. And then the next one at 2 pi over 3, I'm back at that 0.866 or 87. And then I'm at 0.7. And then I'm at 1/2. And I'm all the way back down to 0. Okay? I don't know if I'm moving way too fast, but you see that I've got these values. This was 1. This was that one that's about 0.87. This one is like 0.7. This one is obviously 0.5. And then I got 0. So I've just plotted these 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 points. Okay, and you can see I got this like little mountain shape. Well, now let's plot the next 9. 7 pi over 6 is negative 1/2. That puts me right here. 5 pi over 4 is negative 0.7. So that's going to put me right about here. 4 pi over 3 is negative 0.87. So it's going to be about here. And 3 pi over 2 is negative 1. Here. 5 pi over 3 is negative 0.87. 7 pi over 4 is that negative 0.7. And 11 pi over 6 is negative 1/2. And 2 pi is 0. Now, you might say, well, wait, how are you figuring out where these go? Well, think about this. Notice I have my y broken up into, if negative 1 is right here, then this is 1/2, that's 0.5. And this is 3/4, so that would be 0.75. Okay, so that right there is going to be 0.75. So clearly 0.7 would be a little bit right there, and 0.87 would be, down about there. I'm kind of just judging it based on what that looks like. Now at this point, hopefully you can see what we have now. This is called the sine wave. Okay, and so if I connect these points, it looks something like this. This is very curved. It has very, very few like flat sections. Okay, so it should look something like that. Okay, there we go. That's the sine wave. So if someone says, hey, what in the world does y equals sine x or f of x equals sine x look like? That's what it looks like. This is the sine wave. And now we can actually stop at this point. If someone says, well, why? Why would you stop right here? Well, because at this point, we've gone all the way around the unit circle. And we're just going to start over. So think about it. We would repeat this pattern. And we would do this exact same thing over. That's why it's called the sine wave, because it just there's just this constant wave to it. Okay? Not too bad. Not too bad. So that is the sine wave. Okay? So now, think about this. This is going to be a time where I'm going to encourage you to use a calculator to get some decimal approximations so that you can graph this. I've left some paper that's going to kind of simulate this graph right here for you to make your own. Okay, so I want you to watch me work my way through cosine, and then you're going to try these on your own. And I think you're going to do great. Okay, so now I got to shrink this screen down a bunch and steal all of this off of here. And then I'm going to do cosine. So let's go delete. All right, and let's get rid of all that and all those little dots and that. Okay. Now, what I'm going to do is I'm going to take this this x and y table that I have here. Oh, I brought that line with me. And I'm going to redo this, but for cosine. And I've got another graph down here, but I don't know that I like this graph yet. Okay, it's a little bit too much. Doesn't give me enough room. Okay. We'll try it right about there. Okay. And hang on, I gotta move this a little bit more. All right, let's try it. Okay, so now this is going to be a little bit different. Name of the game now, f of x. We're saying our f of x is equal to cosine x. Or in other terms, y is equal to cosine x. The output is equal to whatever cosine gives us. So now we think about this. Now, this is where we've got to get over the fact that we see a y right here, because I'm not talking about the y coordinate anymore, because why? We're talking about cosine, and cosine is always about the x coordinate. So now we're going to still work our way around the unit circle, which is where all these values come from, but we're going to think about that x coordinate, okay? So let's do this. All right. Okay, so at 0, what is the x coordinate at 0 radians? Well, it's 1. And then what as I go up to, pi over 6, what's the x coordinate? Well, the x coordinate doesn't reach out quite as far. It's square root of 3 over 2. And at pi over 4, it's square root of 2 over 2. And at pi over 3, x only goes out to 1/2. And at pi over 2, which is also 90 degrees, x is 0. That angle is straight up. It's on the axis, on that y-axis. And then when I get to 2 pi over 3, well, now I've gone in the negative direction, negative 1/2. And when I get to 3 pi over 4, again, I've gone negative x direction, negative square root of 2 over 2. At 5 pi over 6, I'm at negative square root of 3 over 2. And at pi, think about when I go pi is also 180. What is the x value? The x value there is negative 1, okay? And at 7 pi over 6, I don't go back quite as far. I'm in the third quadrant, but it's negative square root of 3 over 2. At 5 pi over 2, 5 pi over 4, it's negative square root of 2 over 2. At 4 pi over 3, it's just negative 1/2. And at 3 pi over 2, also 270, that's right there on that negative x-axis, so that's just negative 1. At 5 pi over 3, it is, I'm sorry, not negative 1. Oh, my goodness. Wrong. At the negative y-axis, what's the 0? Or what's the x value? 0. And then at 5 pi over 3, now we're moving in the positive x direction. We got 1/2. 7 pi over 4 is square root of 2 over 2. 11 pi over 6 is square root of 3 over 2. And 2 pi, we come back to 1. All right, now let's plot these points. Now, you might say, well, we're seeing the same values that we did on sine, so it should look the exact same. And you're sort of right, but you're not completely right. Because cosine definitely looks a lot different than sine. And that seems weird, but it does. Okay, so we're going to say that these tick marks that are right here are like the half. I'll just kind of go blue. We know they're the half, so we don't need to see those. I don't want to confuse us with thinking that that's 2. Okay? All right, let's plot this. So at 0, we start up at 1. At pi over 6, we're still pretty high. We're up there at 0.87. It's actually a little bit higher than that. At pi over 4, we're at that 0.7, which is like right here. And at pi over 3, we're at 1/2, which is right here. At pi over 2, we're at 0. At 2 pi over 3, now we've already gone negative. 2 pi over 3, we're back at negative 1/2. At 3 pi over 4, we're at negative 0.7. At 5 pi over 6, we're at negative 0.87. And at pi, we are at negative 1. Okay? And then we start working our way out of the negatives. At 7 pi over 6, we're at negative square root of 3 over 2, or negative 0.87. At 5 pi over 4, we're at negative square root of 2 over 2, which is at negative 0.7. And at 4 pi over 3, we're at negative 1/2. Okay? At 3 pi over 2, we're at 0. At 5 pi over 3, we're at 1/2. At 7 pi over 4, we're at that 0.7. And at 11 pi over 6, we're at that 0.87. And lastly, at 2 pi, we're back up at 1. Now again, this might, I'm not drawing this great, and it might look like it has some straight sections, but this is super duper curved. And it should look something like that. Man, I'm not drawing that part really well. This part should look more curved like that. Okay. Should have a nice curve to it, and then it curves back, something like that. All right. Okay, it should look like that. And you go, man, it does look like the sine wave, but it's like interrupted. So this one, this is the cosine wave, but no one ever really talks about the cosine wave, because the cosine wave and sine wave are the same thing. One's just shifted over. If you think you look back at that compared to that. The sine wave started, if you think about it, the sine wave started over down here, and it went up, down, and back. And cosine starts at the high point and then dips down and comes back up. and then dips down and comes back up. And so cosine just starts at a different point. It goes through all the same function, all the same values, but cosine starts up here, dips down and comes back up. Sine starts at the origin, comes up, goes down, and hits the axis. Okay, so this is the sine wave. This is technically the cosine wave, but nobody calls it that. They just talk about sine, and they call it the sine wave. They might call it the cosine function. Nobody really calls it the cosine wave. All right, but this shows you, if you have a table, you can come up with all of your input-output values, and you can graph them, and you can see what these graphs look like. And that's what we are going to do today. So you are now going to try to do this on your own. I'd like you to start with these. You're going to try to recreate these graphs, and then you're going to try to do tangent, cotangent, secant, and cosecant. Now, the only downside about those last four is that they have asymptotes. Okay, and if you don't remember what an asymptote is basically an imaginary line that passes through a graph. So like I could say this one has an asymptote right here, a vertical asymptote right here. Okay, put that over. And what that means is as our graph gets close to this, it freaks out and it goes almost vertical. Like you've seen it before where you've seen things that, are, I don't have this right, look like this, and they're moving, and all of a sudden they get close to that asymptote and they go, woo, and they go way up. And then usually on the other side of it, I'm sorry, I kind of curled the tip of that. I didn't mean to. It shouldn't have that little curl to it. Okay. And then on the other side of the asymptote, maybe it comes down like this, or maybe it actually comes up from the bottom like that. We've seen things like that. But an asymptote is an impassable line. So you go, well, what causes an asymptote? What causes this? Well, that would be like when you have something that says y equals 1 over x plus 1. Okay? Well, why would that have an asymptote? This is going to have an asymptote because this x cannot equal negative 1. Why can't x equal negative 1? Because if x were equal to negative 1, then this whole denominator would equal 0. And that's impossible. So we could say that this right here is the x value. Now I know it's on the wrong side of the axis and all that kind of stuff, but we could say that is the kind of thing that would happen at x equals negative 1. We would have this asymptote where there is no value. You can't plug in a negative 1. Bad things happen. And so you're going to get the same kind of thing in tangent, cotangent, secant, and cosecant. There's going to be some asymptotes, okay? And so you got to be ready for that. They're not going to be these nice smooth graphs, smooth waves. So you're going to have some asymptotes. But I'm going to go over those, and hopefully you'll make some sense of it, all right? Hey, have a lot of fun with this. Good luck.